Okay guys, we're back. And now we're starting with pie charts, which you've seen before in life, I hope. It's a circle divided into a section. Each one represents the proportion or the relative frequency that something shows up. So again, if something shows up, has a chance, 50% chance of having happened, it should take up about half the pie. Now, in order to find relative frequency, the first thing you have to do is add up all the frequencies together so you can divide by that number. So Weatherford College students were asked how often they wear a seatbelt, and they were able to respond with always, most of the time, sometimes, rarely, or never. And you got these number of people. When you add all of the numbers together, 2518 plus 1257 plus 552 plus 324 plus 125, you get 4,776 respondents. So if I want to do the relative frequency, I need to take all of these numbers and divide by that 4,776. So 2518 divided by 4776 is, I'm going to go 3 decimal places, 0.527. 1257 divided by 4776 is 0.263. 552 divided by 4776, 0.116. 324 divided by 4776, 0.068. And 125 divided by the same thing, 0.026. Now I could use that to make my pies. I mean, it doesn't have to be perfect, but I'll do my best. 0.527 should be halfway and a tiny, tiny bit more. This is the always, which is 52.7% or 0.527. Let's do another color. 0.263. So a quarter, but a tiny bit more. This is most of the time. 26.3%. 0.116, that's a little less than half a slice. Or a quarter of a slice, I mean, half of a quarter. Sometimes at 11.6%. And then the last two, rarely at 6.8%, and never for those rebels, probably don't wear masks either, at 2.6%. Now how do I get the percentages? Again, it's the decimal, move the decimal place twice to get the percentages. So how can I use this? What percentages of respondents responded always? Well, it's just the decimal moved 2 decimal places, so 52.7%. What percent of respondents answered never or rarely? So we can add the 0.068 plus the 0.026 to get 0.094. And again, turn it to percent, 9.4%. And suppose a representative from the CDC says 52.7% of all college students wear a seatbelt. Is that descriptive or inferential? Well, what do we remember? What descriptive is a statement about a population that's true. Inferential statements are ones that take statements about a sample and try to explain a behavior about the whole population. Since only Weatherford College students were asked, for the CDC to say that all students wear a seatbelt, that would be inferential because it's taking a specific result and making a general statement. And that is all for 2.1, but we will roll into 2.2 now. So 2.2 is exactly the same as 2.1, but instead of organizing qualitative data, you are now organizing quantitative data. If the data is discrete, meaning you have finite answers, that was like the number of siblings you have or number of goals or touchdowns you score, it's going to be almost exactly like qualitative data. Researchers are interested in determining the age at which adolescent males show the greatest growth. The age of maximum yearly growth is as follows. And there's the list of 1, 2, 3, 4, 5. Looks like 24. Yeah, it says it on number 1. Construct a frequency distribution. And then draw a histogram. The histogram we talked about in the last video. Okay, so let's start. Age of max growth. It looks like it goes from 10 all the way to 18. Make sure to put 11 in there. If you're going by numbers, you need to include the values even if there's no answers there. And they'll have to be represented in the bar graph or histogram as well. So 10-year-olds looks like 1. 11-year-olds 0. 12-year-olds 1, 2, 3. 13-year-olds 1, 2, 3, 4. 14-year-olds 1, 2, 3, 4, 5, 6, 7. 15-year-olds 1, 2, 3, 4, 5. 16-year-olds 1, 2. 17-year-olds 1. 18-year-olds 1. I hope this adds to 24. It does. So here's our frequency. I'm going to do relative frequency again. You take that number and divide it by the 24. I'm just going to put the fractions in there for now because when we're doing the histogram, it says just the regular frequency one, so we don't need the relative frequency for that. But if you want to turn these into decimals, you may do so. And again, the total for a relative frequency chart always adds up to 1. So we'll do a histogram of frequency. And it needs to go up to, it looks like 7. So I'm going to go up probably to 8. Okay, 10-year-olds, there were 1. Since the histogram, remember all the bars have to touch. Use alternating colors. 11-year-olds, 0. 12-year-olds, 3. Now you're thinking, how do I make the bars touch if one of my bars is 0? It's like an empty bar here, down at the bottom. I swear it's touching. 13, 4 people reported that they had the biggest growth at 13. 7 at 14. 5 at 15. 2 at 16. 1 at 17. And 1 at 18. So again, this is more of the same stuff that we did in 2.1 for discrete data. In the next video, we will do continuous data and the differences and the different ways you can represent continuous data.